welcome to the panel discussion. In this panel, we're going to have the 4 invited speakers. So Rachel, Sarah, and Martin that already gave their talks, and Xiang that is going to give his talk in the next session. And we also have additional 4 panelists, Mohit Bansal from UNC, Greg Durrett from UT Austin, Samir Singh from UC Irvine, and Aida Nematzadeh from DeepMind. So the way we're going to do it is I'm going to ask a question, and then any of the panelists who want to go first, you can just start talking. We're going to make sure that you all, or at least most of you, answer most of the questions. And I have no idea how long it's going to take, but we might have time in the end for questions from the audience. Okay, so the first question is, what do you think is the main challenge in common sense reasoning and in NLP in general right now?
I guess maybe I can go first. I think one of the main reasons is one of the main challenges is identifying exactly what common sense reasoning is and how to evaluate that, in the sense of the question we struggle with right now is, do these models know common sense or not? And that requires both defining what exactly are we testing for and how to test for it. But, yeah.
Yeah, to add on that, I want to also say, like, because common sense reasoning really emphasizes a lot on the reasoning skills aspects, where reasoning skills are usually hard to be just captured by a single data set or even a suite of data sets. Like there's a lot of things about robustness, about like out of distribution generalization, which are pretty important properties of these common sense reasoning skills. And it might ask for a new evaluation protocols that go beyond just data set based evaluation, which are still pretty open problems to us.
I don't know that there's a single thing that I would say is the main challenge, but I think one of the big issues that I see is that, you know, we can build these huge resources that capture common sense inferences under certain circumstances, but then knowing in context when those inference rules apply or not, I think is a major challenge, and being able to model more, being able to take into consideration finer grained context to determine when an inference rule applies or not is, I think, a very big and interesting challenge.
Maybe you can briefly continue on that. Hello, everyone. Great to see you. So, yeah, so I think just the 2 words in common sense reasoning, right? I mean, they need a lot of definition, discussion, description in themselves. Like what is common sense? Socially different, culturally different, morally different. Is it about the why or the how or the when or the where, right? So, I mean, there's also like different types of common sense types to be defined. And then also the second word is reasoning. So what kind of reasoning? For example, are we calling reasoning as forcing a model to explain what it did, right, behind the scenes instead of being black box? Or are we asking the model to generate parts of a common sense knowledge graph? So there's also different kinds of causality versus explainability and other kinds of definitions of the word reasoning. So I'll leave it at that for now.
Just to add to that, I think maybe to make the challenges a bit more specific, I agree with what everybody said, and also specifically with what Rachel was talking about. But I think an interesting challenge when it comes to common sense is actually building a retriever system to be able to use the existing knowledge graphs and retrieve the right knowledge. And for like a lot of other tasks where we use knowledge bases, we can rely on, you know, just semantics and word structure to retrieve knowledge. For common sense, it becomes a bit more subtle, and because of it, it's a bit more complex to actually get the right knowledge, even when we have supervised data. So I think thinking about like what we need to encode to be able to actually retrieve knowledge a bit more accurately when it comes to common sense situation is an interesting direction.
Yeah, I think that, I mean, I agree with what's been said so far and don't have a ton to add to it. I guess the sort of issue with common sense is that in many ways it's kind of a dumping ground for like, oh, we should be able to handle that with like common sense or whatever. And it is kind of ill-defined. I also think with the rise of pre-trained language models, they do sort of have these abilities that look like common sense. And so then we should assume they should be able to do all of common sense. But of course, reporting bias is the main thing that's going to make them not able to do that. So yeah, I guess I would agree with kind of articulating exactly what we expect is probably important to be able to evaluate whether we can do it or not.
Great.
I guess sorry, I guess I have a bit of an adversarial follow-up on that set of answers. You know, once you have that definition, what is that going to enable you to do?
I guess if you were directing that at me, I'll start
off.
No,
I'm directing it at everybody. You know,
well, yeah, no,
I mean, 5 of you gave the same answer.
I guess, like, I think I mean, I think that when you look at knowledge-based question answering, for example, there's a very easy question of like, oh, is this thing in the knowledge base or not? If not, we should be able to say, I don't know, or, you know, just not give an answer, right? It's like, I think it's fairly clear, like, what to do there. A lot of common sense stuff, and I mean, we've been guilty of this as well in like some recent work, but, you know, we just kind of write stuff down and it's like, oh, all right, you know, the model will figure it out or whatever. But I think if we have a sense of like, okay, you know, this is focused on physical common sense or social common sense, and obviously there are, you know, data sets and such for targeting these, like, I think if we have a sense of like kind of drawing some boundaries and don't just kind of expect everything, like there was a comment, I think, from Colin at a workshop yesterday about like, well, we can't expect to be able to encode all of Wikipedia into a neural model, just information theoretically. So like we should try to kind of isolate a smaller set of common sense and evaluate that.
I also want to follow up on a comment. I think this is from something that Mohit said about the definition of what kind of reasoning we want to be able to do. And one thing that, I mean, it's not exactly a question, but maybe I'm just going to ask for your thoughts about this. The way that we have been struggling with defining what common sense reasoning is, we usually just default to that's what most people know, or what is common to most people to know. But some of the reasoning that we are working on, reasoning types that we're working on, is arguably actually not very easy for people, especially explanations. I think that we often say that the models that we train are not given faithful explanations, but people also tend to do that. Sometimes we make decisions emotionally and then try to post hoc explain them rationally. So what are your thoughts? Is there any is necessarily the limitations that humans have are going to be also limitations of models, or maybe it's independent?
Yeah, that's a great question. So I think faithfulness is a good example, but also like causality in some sense, right? I mean, if you want to move past the definition of common sense reasoning, and let's say we are looking at something that's popular these days, which is these large-scale pre-trained language models, and seeing whether they can do common sense reasoning. So one line of work I think that's really important is checking their consistency of beliefs and also their causality, right? If they believe in A, and then maybe for humans, right, A leads to B and B leads to C. So that is that cause and effect or causality chain also being developed in these language models, and most of the time in current models it's not. So it's basically a bunch of isolated facts that are not really being consistently and causally being reasoned across in any sort of way that humans do. I mean, ignoring the example, like the exceptions where we sort of are maybe fooling ourselves in terms of our faithfulness of the real reasons we did. But just to be just to think of it from like cognitively, right? I mean, so these models don't have any sort of causality or consistency in their beliefs. I mean, they do a little bit, but there's a long way to go there. So to me, that just to make it a little bit more low level would be a pretty interesting main challenge of current common sense reasoning directions.
Okay, thanks. Any other comments on this question, or should we move on? Okay, I'm going to move on. There are plenty of other questions. What is the most promising or exciting line of work in common sense reasoning right now, in your opinion?
I can start talking about this question. So it might not be a very recent trend, but at least it's something that maybe I've been paying attention to more recently. But it's basically to be able to evaluate existing models in a zero-shot way. I think a lot of the work that I knew like last year or so basically tried to train models specifically for a common sense data set, which is important and interesting, but I always worry that we're going to go to a regime where we're training specific models for specific data sets, as opposed to testing general ability of common sense reasoning. And I think in the last 6 months, we actually have started seeing a few more papers that are doing zero-shot evaluation. So I think thinking about what we want in terms of evaluation and how we can actually make sure that the model is behaving in a sense that we consider common sense reasoning or common sense understanding is important. And I'm excited about it.
I'll add that I think the recent developments with large language models and trying to understand what they capture and don't capture about common sense knowledge is very exciting, because I see it as a sort of continuation of earlier lines of work on acquisition of knowledge from text, whether it was earlier work on like the NEXT system from University of Rochester, or DIRT by the discovery of inference rules from text by Lin and Pentel, and Chambers and Jarafsky style learning of narrative chains from text. Now, this seems like sort of the logical conclusion of that, or the logical next step in that line of work is trying to understand what these large language models are learning about the world. And I think it will be interesting to see what in the limit is, what's sort of the limit of what can be learned from text, and the different kinds of modalities that we might start to need to look to, because we know that humans don't just learn from language, we learn about the world through interacting with it. And so I think there's already a lot of exciting work in learning from different modalities, but I think maybe the advent of these language models might speed that up, because we'll sort of hopefully start to understand what are the limits of what can and can't be learned from text.
I can go next. So yeah, I agree with that. I think one sort of aspect that I haven't seen enough of, and I think maybe Jonathan Brand has a line of papers that are most exciting about these, is to look at pre-training and try to see, are there ways to augment data during pre-training just by creating text and sort of pre-training these models so that their capabilities in common sense reasoning improves. So I think even things like numerical reasoning and temporal reasoning, things like that, can they be improved just by adding some text to the language modeling objective during pre-training? That's been quite exciting to see. Yeah.
I'll just add one quick thing onto what Rachel said, which is I just put a link in the chat. There's this recent paper by Forough Abshahi and Jennifer Lee from Facebook, led by them and with a few other folks. And I think that one very cool thing about this paper is they do this sort of conversational elicitation loop, basically. So I definitely think that grounding and such are good answers long-term, but I think short-term it would be great if we had interactive systems, then we could get sort of the information that we need, like let's say just what happens to be missing for this particular inference that needs to be made. If we could get that, maybe there's a kind of bootstrapping, we can go from where we are to something new and better pretty quickly.
Maybe briefly, just continuing on that, I'm also I think a big believer in the interaction side. So it can be conversational, like Greg mentioned, but also going back to maybe I'm biased, but like towards a multimodal thing, where as for example, when we are growing up, we interact with a lot of things, we push them, touch them, get reactions for every action, that sort of thing. So going more into the grounding side of things and being able to other sources of common sense knowledge and seeing how they interact with text and what's the upper limit sort of text, because obviously there's a good understanding of a lot of things being implicit and not being spelled out or not being said explicitly, right? And these things could be more implicit knowledge or visual knowledge or interactive knowledge. So there's, I mean, obviously some on this, and also, for example, looking at videos, right? Being able to learn from tons and tons of videos, not just for multimodal tasks, but also text-only tasks. Can they improve physical common sense or temporal common sense? So that I think this is an exciting time to be able to make progress in these joint areas because of the individual progresses that have been made.
Yeah, I just want to add to what Ida started with the generalization issue. I think that's a pretty important aspect of looking at common sense reasoning. I feel like the work done in past 2-3 years on looking at this common sense reasoning, or just generally reasoning capability of NLP model, are kind of focusing a little bit more on whether these models can recall knowledges, like recover these one-hop factual knowledge kind of things a lot. But there's another important parts of the reasoning capability is multi-hop reasonings, where you can make robust inferences based on multiple hops of knowledge. And this was kind of a less explored, but we do see a lot of work coming up in the past year or so. And I'm particularly excited about like how to evaluate these systems kind of logical reasoning capability in a robust way and in a faithful way. I think, like, for example, I know Mahir's groups have done some great work on looking at the proof graphs of these reasoning systems, where these proof graphs can provide some faithful explanation of what the system is really doing when they are trying to answer a question, and to see whether the model are just learning some spiral patterns between the answer choice and the questions, or they really can do this multi-hop reasoning in some inner working manner. I think those are pretty interesting directions to just help us understand better why this system works so far, so that guide us to design like a more meaningful, maybe neuro-symbolic systems in the future. Yeah.
Thank you. Are Sarah and Martin on this call? I haven't heard them.
No, they don't appear to be.
Oh, okay, never mind. Any follow-ups on this, or yeah, anything you want to add? Okay, I'll move on to the next question. So what is the role of knowledge bases in the times of pre-trained language models? So the first question is kind of like a rhetorical question, I guess. If you're in this workshop, you probably don't think that language models already capture all the knowledge in a perfect way. But what are some examples in which knowledge bases are useful? And if you think that they're not useful enough in their current, like in the existing knowledge bases are not useful enough, then what do you think are the main obstacles to making them more useful?
I can start first, because I feel like I start my research in common sense reasoning because I believe in knowledge base. As I work for like the past 2 years, I feel like less confidence of using knowledge base or like expanding the knowledge base to really solve this problem. I think for one of the major problems is all we know that it's just super expensive to maintain, to expand, to populate this kind of knowledge graph to really work for the fast evolving applications and data sets we've seen in the past couple of years. And I feel like the speed we can do with really manually, I mean, like even automatically plus manual verification of maintaining this knowledge base is not gonna catch up that speed. So really, I feel like, for example, I'm pretty excited about the idea of like COMET, like where we really think about language model as an inference engines of producing this knowledge on the fly. I mean, but there are definitely much more to do. Like the fundamental question could be like whether these kind of pre-trained transformer are really good architectures for building a dynamic knowledge graph inference engine. But I just personally think that the like using knowledge graph to do augmentation of reasoning process or inference process might be much limited by the coverage and just the diversity of the knowledge obtaining side. But I do think that using knowledge graph to do some grounding and then provide these grounded informations to humans as a sort of a, I mean, of course, we need to guarantee it's a faithful explanation of what the model is doing. With that, I mean, maybe that can provide some interpretability to the humans so that people can provide feedback through these grounded informations to the system, which I think is still a pretty open question. Like, I don't see something that is really working on this space yet. Yeah.
I can add maybe some additional usefulness for knowledge bases that I don't think we can really get with pre-trained language models. So one thing that we get with a knowledge base that is interesting to me is the ability to be able to actually assign some like ground truth or like some actually like value of how much we rely on a, edge in a knowledge base. And if we are really trying to verify something, I think at the end of the day, whatever we get out of a language model cannot really tell us if something is truth, if something is probable, given some other word, which is our knowledge base, and how much we can rely on it. So basically for verification and fact checking, I think we will need knowledge bases no matter how big our models are. And then I guess the other part of this question is, if we think they would replace language models, I think it really depends on our goals and tasks and what we are going to use this knowledge bases for. So it's possible that for some of the current benchmarks, we can, replace the knowledge base with just use a larger language model and do like very well. But it doesn't mean that we don't really need knowledge bases.
I'll bring a slightly different perspective to why knowledge bases struggle, especially for common sense language and reasoning. I think one of the key aspects of common sense is sort of a presupposition of like common knowledge that's common across some population. And it's usually anything that's common sense won't be agreed upon by 100% of the people just in this absolute fact. But usually there is some context that allows you to say, okay, yeah, in this context, Apple is a fruit or something. Otherwise, Apple might be a company or whatever it is, right? And the struggle I have with knowledge bases or common sense knowledge bases is that they don't really have an easy way to contextualize their edges or entities or reason, like if this is true, then this specific knowledge exists. And with language models, that's as trivial as just sort of stating it and then conditioning it on the context. So the contextuality of knowledge bases is one of the big problems, especially for common sense reasoning, I think.
So are there some good examples of these contextual knowledge bases? I'm not an expert on knowledge bases by any means. So maybe Samir or Xiang, but that seems like an important.
One of the talks that we heard earlier from Martin was he was talking about Atomic, which is also a knowledge base, but it's built.
That's what came to mind. Like Atomic 2020, the new version also is pretty good. But I was wondering if like there's some other ones that I missed. Okay, thanks.
Maybe there are additional ones that I'm not aware of. I'm actually, I'll be happy to hear about it too.
Yeah, so maybe since I'm already on mute, I'll maybe give my 2 cents. Knowledge base, I mean, to me, if we assume there's some contextualization in them, I think it's a good balance of like just precision and recall at a very high level, right? Where you can have some accurate sort of subset of rules and maybe soft constraints that could come from knowledge bases or knowledge graphs. The more open-ended, free-form, and sort of ever-growing kind of information that you don't need to curate can hopefully, the recall side can come, including more context, could come from the free text-based pre-trained language models. So that in that sense, to me, I think there's still hope of complementarity, especially, I mean, all these discussions need to also take into account the feasibility and the size of very, very large language models that most people cannot use or fit in their general experiment setups. So there's that angle too, that we may not have GPT 1000 and just like there's no feasibility at some level. And then the other thing I feel that knowledge bases can be pretty useful for is on the evaluation side, right? So again, going back to some initial points about being able to measure causality or belief consistency in large scale language models, the knowledge bases can be used not just as some soft constraints for training, but also during evaluation, we could check whether when we probe them to prove certain kinds of consistencies or causalities, like that there's a good medium to be able to match that against. So that's another maybe a small point in terms of how they would go well together. And then the third point is, I think Yejin and where like you've shown in the past, right, that there is a very good sort of advantage of generalizability when you have neuro-symbolic kind of combinations, especially you showed it for atomic 2020 neural decoding, I think, paper and talk. So that's another maybe discussion point about having more generalizability if we have both of these together.
Yeah, maybe I'll follow up on that. I think part of the contextualization part is a really major issue, and it's expressed in multiple ways. One of them being when you do have the knowledge in the knowledge base, how do you decide which knowledge is relevant, and how do you maybe also how do you incorporate it into a neural model? And I think part of the trade-off there is something that is also the trade-off with how the knowledge is expressed in the knowledge base. If you look at earlier knowledge bases, they expressed it with logical forms, so you have more context. If something is true, then something else is true, as opposed to now, when you use ConceptNet, for example, you have something as ill-defined as a person is in a restaurant, which could be interpreted in so many ways. So I guess there's this trade-off of how much knowledge you can collect versus how expressive and contextualized it could be. Yeah, that's just a comment on that. Okay, anyone else wants to answer this question?
Yeah, I have a quick comment. Yeah, I have a quick follow-up. I also believe like the current structure knowledge base is not that powerful in our common sense reasoning models, and I think one major reason is like the incompleteness and the noisiness is from the binary structure of the definition of our relationship in our like ConceptNet or other similar knowledge graphs. So I think that's why I think a more promising way is to use a whole textual corpus, like some people call it a virtual knowledge base. Like it's just like a corpus of all the common sense facts or like factual facts. And for example, like William Cohen, like from his team, there is a work for like differentiable reasoning over a virtual knowledge graph. So in such like kind of knowledge base, knowledge corpus, we could have like use pre-trained language models as a way to encode all the facts we have, and to design a retriever, like a query understanding module to search over this very large text corpus as a knowledge base. I think that would be a very, very interesting future direction.
Yeah, thanks.
Can I just add one quick thing to that, which is that, yeah, I think that there has been this sort of blurring of lines between like, what is knowledge versus what is training data, and then for language models, what is their sort of ability to do reasoning versus what is the like maybe common sense that they have stored in them. So I mean, I think the nice thing about having an explicit KB is it makes things explicit. You can do like retrieval, or you could dynamically generate the KB at test time, but there is this really, when we kind of think of, especially in the atomic comet world, is like all knowledge is also training data, and then all models are also knowledge bases. Like I don't really know how to answer this question because of how blurry that line is.
Yeah, that's a good point, and it goes back also to what Ida said, that when you actually need might be slightly rephrasing it, but when you actually need to verify facts, or when you need something to be more accurate, then knowledge bases are more reliable in that aspect. Okay, let's move on to the next question. So given limited resources, should we spend them on expanding knowledge bases or find alternative knowledge sources? Which is kind of like, probably some of it was already covered in the previous question. And then if we are, if your answer is we should invest these resources in knowledge bases, then what kind of design choices, like the representation of knowledge, the collection method, and type of knowledge you would think be most valuable to focus on? You can think about it as a more concrete question. Like if you, I don't know, think about your current research budget. If you can only spend it on either training a language model or expanding or building a knowledge base, what would you do?
Maybe I'll start here. So I think this is a complicated question with lots of dimensions. I think one dimension that I will bring up is, I think we need to be very almost active in the sense of active learning, right? Like we need to be targeted to current language models and what they capture and what they don't capture when we are doing these resource gathering. I think the common sense is something that, you know, we say things like it may appear in the text, it may not appear in the text, and then to what level is the model abstracting? If we are not aware of what the models are actually doing, what we'll end up doing is gathering a bunch of stuff that in the short term might look like the models might not know, but just a slightly different model does get to know. So thinking a little bit fundamentally about what can be learnable from a pre-training corpus, and what is the common sense that's probably not covered by it and not covered by the models right now. Those might be the ways to think about data gathering.
I can add, I guess, a few points to that. So I think for me, this question is a hard one because defining who we is maybe a bit vague. If you're thinking about like the research community right now, I think what I need to better understand is basically whether the current benchmarks that we have and the data, also the knowledge bases that capture common sense, are good enough for continuing research. And if I do feel there's still like, you know, there are a few open questions that we can address using these existing resources. But thinking about like whether we want to, you know, use expert annotation or do crowdsourcing or do automatic, I guess, collection of the data, that kind of really depends on how we're going to use this knowledge and how much we want to rely on it. So there's like, at least thinking about like the types of resources that are created using expert knowledge and a bit more slower and paid a bit more money, I kind of feel like they are the resources that are still around. We still rely on them, we still use them, which is maybe a good sign. But if you, I guess for a research project, we are not really thinking about creating a research that lasts long or like a resource that we really want its correctness. Maybe relying on crowdsourcing or automatic annotation is the way to go.
I really like the implication that the answer to this question should be neither of these. You should first focus on building better evaluation benchmarks.
Just want to add on that. My take on this is like maybe we can change the mindset a bit. I think about when we are building a downstream task or building a system for a particular use case, how to have a component where we can solicitate this common sense knowledge that can be used to solve the task, and try to put those things together into a let's say a task specific common sense knowledge base. I think that might be an easier starting point to make things more focused and more target. For example, like if we have ways to externalize the reasoning process for answering questions, then maybe we can, starting from those externalized factual knowledge, triples or graph, and then ask human for feedback on correcting or modifying some of them, and put them aside into a knowledge base and think about whether these task-specific knowledge base can be transferable to the other task or to merge into some more generic knowledge base, things like that. Just my 2 cents. Yeah.
Samir, I see your hand is raised. I don't know if it's from earlier or you want to say anything else. Oh, okay.
No, that was from before. Sorry. Yeah.
Okay. Rachel, do you want to add anything?
Sure. Yeah, I think to approach this from the perspective of research at the AI community level, I think there's obviously been a lot of excitement about large language models and what they're capturing by way of common sense. But I don't think that that needs to be at the exclusion of research on knowledge bases. I'm sort of reminded of sort of a parallel conversation that's happening in semantic representation. Do we really need explicit representations of semantic meaning, or can we just have everything be implicit? And I think the value that these sort of structured representations add is that they, as Mohit was saying before, allow us to get a better handle on understanding what these models are doing. They can be useful in terms of evaluation or in terms of helping us debug models when a large end-to-end neural model doesn't do what we expect it to do. Then, without these kinds of structured resources, then we perhaps have less tools at our disposal to try to go about debugging or evaluating the large neural models.
Okay, great. Any follow-ups on this, anyone, or should I move on?
Yeah, I mean, just like what Rachel said, also, like just like another way to decide to spend money on both is that the KGs and the KPs don't have to be just for input, but they can be for output, right? I mean, basically they could be used to force a model to explain itself, hopefully, and then also we could have the model generate these graphs and then have humans, as opposed to like spending money starting. So that would be sort of also related to Samir's point about human and model in the loop, right? So some of the work that Dawi, Kiela, and team have been doing, and we had some collaborations on this. It's sort of a similar idea where you can see which things the current models are bad at currently, and that would be more from a common sense perspective. That tells you what are the main areas in which to expand our more crowds or annotated knowledge.
Yeah, I think all of you mentioned versions of we should pretty much do both, either depending on the task or depending on the type of knowledge that you can expect to find in each one of these. So yeah, I like your answers. Okay. So neuro-symbolic methods in NLP almost always mean neural computation with symbolic knowledge. I can think of a few exceptions, but that's basically what we do, which is already, I have to say, better than a few years ago when almost nobody, some people were trying to incorporate knowledge bases into models, but it didn't really work, and there's much more work on that now. But why do you think there's less work on more like symbolic computation? And yeah, there are some like sub questions here. You can refer to any of them that you want to refer to. So for example, what is the role of symbolic representations and operations? Where can they help, and how can they be incorporated into neural models?
So I guess, yeah, I mean, like for the past couple of years, we like tried to do a bunch of things with kind of symbolic, more sort of symbolic computation in models, and I would say largely failed. I feel like it's just really hard to actually do like if you're taking text as input, like if you're doing reasoning in natural language, it's just so hard to coerce it into a semantic representation that's both, it kind of has broad enough coverage to really do things with, and also admits kind of easy parsing into and then easy computation with. Like either you've got something that's too flexible or it's too rigid and then you can't parse into it. I don't know, at least that's been our experience with it. I do feel like there is a sort of kind of, you know, there is a class of things like Ray Mooney, whenever we talk about like neuro-symbolic stuff, he always like beats up on us for, you know, not being able to handle recursion or things like that. You know, he like kind of prologue style, like what, you know, who is the like mother's brother's first cousin's, you know, roommate or whatever, like those kind of queries are very naturally modeled in a symbolic way. I'd say we just don't have that many problems that really have this structure of like, okay, you've got some, you know, extremely kind of, you know, let's say system one, whatever kind of input, and then you have this very like long sort of computation string that needs to be deduced. When you have problems that do have that property like drop, or just any kind of question answering that involves some computation, people have already found a way to basically predict into a symbolic representation that then does that computation. So I would say we've already in many ways factored out the symbolic piece into the definitions of the problems. Like for example, in math question answering or drop, predict a formula. And so then we don't need to then additionally push symbolic stuff into the inner workings of the models. I would like love it if people could like show me a problem that you know, yeah, that there is some nice like symbolic solution for, but I guess that's my take on it.
One thing I want to add is that it seems like one of the difficulties with symbolic reasoning systems is that it sort of forces you to resolve all kinds of ambiguities that wouldn't necessarily need to be resolved to do all kinds of inferences. And so to the extent that the inference can be done at the natural language level, there are if I understand the question correctly, it's why are we doing computation in these neural systems, and then using sort of symbolic knowledge to complement that versus the reverse direction of doing the reasoning at the symbolic level, and it seems like, you know, being required to map everything into fully symbolic representations forces you to resolve ambiguities that don't necessarily need to be resolved in order to do the kinds of inferences that you want to do in certain cases.
Yeah, these are very good points. Yeah, I'm not advocating to switching to completely symbolic systems. I was curious about why don't I hear about more papers that incorporate symbolic components into the neural computation. But I guess also part of the question is that a part of the answer is that it's also hard to do that, and it's maybe less suitable for language which is more like ambiguous and less structured.
I guess just to add to why it's hard to do, maybe Greg sort of made this point also, but a lot of the times the symbolic operations need to be annotated if you want the models to know which ones to use. And that itself is an additional annotation nightmare that is not as easily crowdsourceable as maybe the symbolic knowledge or textual stuff is. Yeah.
And maybe one last like small point I can make is that it also depends on whether you have that resource, right, for the current language or domain or culturally, socio-cultural situation you're like the task is based on. So maybe redefining and also re-annotating some of that data for every different task becomes challenging. But I guess that's part of a bigger debate, right, of knowledge bases versus large-scale language models. But I think in general, I mean, just repeating my previous and the point that several others have made too is about, I mean, it's still a good way to have some soft constraints to maybe the causality of beliefs inside these language models. So that to me is a good use case of combining neural and symbolic knowledge.
Yeah, it reminds me, I think one of the works that did try to do something like that was, if I'm not mistaken, it's work from a few years ago from Vivek Sukumar's group. And they were targeting NLI, and I think they were enforcing transitivity or something like that, which is really reasonable given the task definition. But then I guess you could find some cases in which people would consider something as entailing, even though logically it shouldn't be entailing. That's why the definition of entailment is so is doubly hedging on both. Most people would likely infer something like that, like Rachel mentioned earlier in her talk. Okay, any other follow-up questions or comments on this?
Yeah, I guess I have a follow-up on some of the things that were said. I think that a lot of the reasons why we don't see symbolic operation having much of a role also stems from the way that this type of task, where we start off with this behemoth language model that's been pre-trained on everything in the world, and then we say, okay, well, symbolic operations should help. We provide some embellishment of that language model to make that happen, give it 500 examples, maybe 1,000 sometimes, and observe that it maybe doesn't do as well as we thought we would. And it seems like there's this huge divide in what capabilities we're offering one, I guess, form of computation versus the other. Do you think that some of this is just fixable by finding the right ways of giving these same advantages to the symbolic systems, or the neuro-symbolic combinations, versus just the current way we're trying it?
Sorry, could you repeat what you mean by some of these advantages?
Well, if you were able to have a neuro-symbolic system that you were able to pre-train at the scale, such that the same interactions you learn during pre-training on language, you can learn in this more theoretically expressive system, would you imagine that you would get the same benefits? Or do you think that whatever you can learn from that neuro-symbolic system in pre-training, you can just get from the neural side as well?
And when you say at scale, like, is it scaling at the symbolic side or the size of the knowledge base? Like, what's the scaling part?
In whichever direction you want.
Yeah, no, so I mean, yeah, I mean, ideally, I think my intuition would be yes, but then the scaling is probably the challenging part, because, I mean, like I was saying, how do you scale the symbolic constraints, and how do you scale the knowledge base, and then also domains, languages, but I guess I'll let others, I'll hear other people's thoughts first.
I think you're muted, Samir.
I think it kind of depends on how the symbolic stuff fits into the whole neural pipeline, right? So it's not as if the symbolic operations cannot be reproduced by neural representations, right? Like we've seen even things like recursion and stuff. If you sit down and design it specifically, you can probably reproduce it. So it kind of depends on, like, if you're throwing in symbolic stuff and we're able to scale it, is it giving it an inductive bias that is not absent from a neural only architecture? Is it giving it more modularity in its architecture that we don't get in the neural things? What is it actually giving you? Is it giving you data efficiency, where you don't just kind of relate to inductive bias, I guess? So yeah, like, and that sort of ends up going into how are you actually combining neural and symbolic stuff. But yeah, that's okay. Yeah. And I think just to say that we've also seen that if you do it the wrong way, I guess we had this paper maybe a year ago or so, Matt Gardner and Sanjay were leading it, where they showed that you have a neural module network which had all these symbolic operations or modules, I guess, and you had some semantics attached to it, but when you do end-to-end training, it can learn to do slightly different things or use input and output in ways that are unintuitive, and essentially starts behaving more like a end-to-end neural system. So the integration of neural and symbolic methods has to be done in a careful manner, and maybe that careful manner requires more annotations than just a lot of pre-training text.
Okay. So I don't know how we are with timing. I wasn't really following. So I think we're, I think we're running out of time. But I also think we covered this question. Maybe if each of you wants to maybe finish with where the, like a really short, like in one sentence, where do you see this research area in 5 years? If you have an answer for this.
Sorry, is it go first? I have a hard clash at 3, so I need to run.
Okay.
So, 2 words would be, I guess I have an unstable internet connection too. Yeah, causality and multimodality grounding.
Great, thanks.
Will those be solved or persist?
Oh, I was saying these should be some of the focuses for the next 5 years, and then I can't really put money on them being solved this person.
Okay, thanks a lot for stopping by, Mohit.
Thank you.
Thanks, everyone.
This is a little bit repeating something that I said earlier, and sort of in agreement with what Mohit just said. But I do think that the developments with the large language models will help speed up the process of determining how much, just exactly how much can be learned from text alone. And I think we'll sort of discover not everything. And that will, my prediction is that will sort of force the question of how to learn from different modalities, and more importantly, how to integrate knowledge acquired from those different modalities back into a single system that can leverage the knowledge from all of those different modalities. So I think that's one area that one direction we're likely headed.
I think one thing that seems to be is a basic direction that we will be able to make progress a bit faster is building models that are going to do well on the existing benchmarks, or benchmarks that we kind of curate in similar ways. And it's I think also very likely that we're going to have models that do well on a range of these benchmarks. But I do think that the problem that probably will persist and is a harder one is having models that do well on data that is a bit more different from the current benchmark. So like models that are able to do common sense reasoning in a flexible way. And basically, if you have like out of distribution, data points where we are evaluating models, and if you evaluate models on basically these out of distribution common sense benchmarks, I still think that will be a hard problem. And I do hope we make progress, but I think like in 5 years, we're probably still working on those problems.
Yeah, just to be slightly contrarian, I guess, I will say that we are nowhere close to knowing how much we can learn from text only. The models can be scaled up much higher. The data we are giving it is still nowhere close to the amount of digital text we have. And till we start plateauing the amount of data and the size of the models, we don't know how much can be learned or not. So I guess if I had to guess, I would say a lot of common sense stuff that we are looking at right now might actually be solved in the next 5 years. And we would be really struggling with, okay, what is not yet learned in the next couple of versions of the large language models. I will say multiple modality will remain a challenge. So that's a persist kind of things where, yes, there are lots of things we can learn there, but learning, like we are struggling with text as a way to learn these the word models, which is exactly what common sense tries to do. And trying to do that in a bunch of other modalities just seems incredibly challenging task. So most of common sense reasoning as we look at it right now will be solved, but multimodality will be persisted.
Just want to add to Samir's point. I think I do agree that it will still be very hard to really set the boundary for where this big transformer, or maybe not even transformer, maybe some new architectures that we don't know coming in a year or two, we actually reach. But I do think we will have a much better idea about what is the inner working mechanisms of these transformers in terms of recording knowledge in the text, in terms of doing multi-hop or higher order reasoning, in terms of out of distribution generalization. I think we will have a better understanding, at least in the next 5 years. And therefore, I think we have a much better chance of influencing these models in terms of their behavior, of what they should learn, what they should unlearn for a particular downstream task or use case or domain. I think that's kind of, I'm optimistic about that progress can be made. But I think that the question will still exist about like what is the right way of categorizing common sense knowledge in terms of different utility, and what is exactly the definition of that. I think this kind of debate will still exist, and personally, I don't think we'll have to make that very clear as a clear cut about what is this knowledge, what is that knowledge, but we can still make progress in terms of making our system working more like a human-like behavior by enriching the knowledge the system have, and by making it more faithful in terms of multi-hop reasoning and this out of distribution generalization. Yeah.
Let me just say, where I don't want to see this in 5 years is like there's like 34 common sense benchmarks, and all you can do is just train a big pre-trained model and just ingest every common sense thing possible, and then be like, oh, we're at 67%, but you know, if Google just gave us another $1 million, maybe we'd be at 68%. You know, I think what would be really cool, and I don't really know how to approach this, we like thought about it a little bit but made no progress, but is like have a sort of narrow domain, something sort of like the baby data set a while ago for memory networks, that like, you know, it needs a robust base of common sense, but basically see how far we can get with that. Like in the context of like a data set like that, what's in the existing pre-trained language models, what can we easily write down, and just sort of see how easy it is to actually like sort of solve common sense in some relatively narrow domain. Now, maybe there's already something out there that I'm not aware of that kind of does this, but I think it would be nice to start from a kind of success story rather than kind of broad domain failure stories where like we get, you know, 67% accuracy or whatever, and it just gets really hard to push. So yeah, more of a high level meta research thing rather than specific, but yeah.
Okay, great. Thank you for your very insightful answers. I think I mean, I didn't monitor the chat. I think there were some questions there, so I apologize. We did run out of time, but I hope you I don't know, maybe we'll continue this conversation over Slack.